Let's talk about determining our rate constant from experimental information. So in this case, I already know that this is my rate constant right here. If you're confused about that, go and watch a different video about how to find your rate law dependent on an experiment. But knowing that that is my rate law for this specific experiment, I can choose any of those experiments to plug in because I already know just how quick they're going based on the orders. So, for example, I'm just going to use, let's use number 3. So it tells me my rate over here in molarity per second. So I'm going to plug in my 1.296 times 10 to the negative 5th, including my unit. I know that I need to solve for my K. And I know that I have my NO2 and my CO2 concentrations. So in this case, my NO2 for experiment 3 is 0.2. And my concentration for my CO is 0.75. I know from my rate law that I need to square that. So I forgot my units on these. I'm going to put molarity and molarity. So in this case, I know that this is going to become K times 0.2 molarity times 0.5625 molarity squared. This becomes K times 0.1125 molarity cubed if I do my math. Then I know I'm going to have to continue using my units. I bring down my original rate because I didn't have to do any math on that side. If I divide out on both sides, I'm going to divide by my 0.1125 molarity cubed. I'm going to do the same thing on the other side. I see that I have 1 molarity on the top, so I'm going to cancel it with one of mine on the bottom. This will become a 2. So then the value that I get is 1.15 times 10 to the negative 4th, 1 over molarity squared. And even though it looks like my S is in the numerator, it's in the denominator units of the numerator. So that means that it's going to go on the bottom. And then that is going to be equal to my K. So plugging all of that back into my original rate law, I have that my rate is equal to 1.15 times 10 to the negative 4, 1 over molarity squared times S times my NO2 times my CO squared. And that's how I find my rate constant using experiment.